Okay, there are some equations that we would like to have you remember and know going into the OST test. The first is some key things when it comes to lines. So we have slope formula, we have point slope formula, we have slope intercept form. And keywords that you want to know. For lines, if you see the word per or constant, those are going to be some keywords. For exponentials, we have our exponential equation, y equals a times b to the x. That's when you see doubles, triples, halves, a percent, multiply. So percent decrease, you still have your a value, but you would do 1 minus your percent written as a decimal. Percent increase would be your a value, and then 1 plus your percent written as a decimal. Given two zeros, when we create an equation, so if we have x equals -3 and x equals 4, we know to flip the signs. So if it's x equals -3, we add 3, so we have x plus 3 equals 0, and x plus 3 is what goes in the parentheses. For our x equals 4, subtract 4, our x minus 4 is what goes in the parentheses there. So you flip the signs when you go from x equals to the factored form. All right, some OST highlights for you. Number one, a function undergoes a single transformation to create g of x. We have f of x, which is the black function on this screen here, and then blue is our g of x function. So f of x is our original, it's transformed to be g of x. So we would say that g of x is the f of x function, and we can look at it, and it's shifted up 3 units, so plus 3. Number two, a scientist is studying wildlife. She estimates the population of bats in her state to be 270,000. She predicts the population to grow at an average annual rate of 2.9%. Use the scientist's prediction to write an equation. So you know, since we have a percent, that tells us this is an exponential. And since it's an exponential, we have to figure out, is this growing or decaying? And it's growing. So since it's growing and it's a percent, we'll use this general form. So our A value is our starting amount, which is 270,000. And then we have 1 plus, and our percent is 2.9. So to write this as a decimal, we move the decimal place 2 times. So we would use 0.029 as our number. Okay, number 3, a system of equation is shown. What are the solutions to this system? Easiest way to do this is throw it into decimals. So let me pull that up for us. All right. Let's do a half slide here. All right. All right, so we're looking for where this function intersects each other. It looks like we have 2. We have 1, 1, and 2, 4. So those are going to be the solutions that we would write in, or if you were taking the OST, you would type in. Number 4, complete the first table so that it is a function. So if something is a function, we want no repeated x values. So you can put anything but -1 or 6 in here. And it doesn't matter what we put for our y values. Complete the second table so that it is not a function. So you would put -1 or 6 in that table. Either one would work. And then again, it doesn't matter what you put in for your y values. The graph of a quadratic function intersects the x-axis at -3 and 5. So I want you to visually think about this. Over here at -3 and over here at 5 is where this function touches the x-axis. So those are x-intercepts. So we know if it's x equals -3 and x equals 5, we can change the signs and write them in factored form. And that is totally fine to write as your equation. If you wanted to, you could FOIL this out and get an actual quadratic. So x times x is x squared, x times -5, 3 times x, 3 times -5. Combine your like terms. So that would work as well. So you could do this one. Oops. You could do this one, or you could do that one. I would say save yourself time and just write the factored form. All right, we have an equation there. It says what values of x make the equation true. This is another way of saying what are the solutions, okay, or what are the x-intercepts. That's exactly what that takes. So we want to see where does this cross the x-axis. So we're going to put this one into Desmos. So right here, we zoom out. It crosses at -1/2 and 3. So those would be our x-intercepts. All right, we have a function, 2/3 x plus 3. It says, what is the value of f of 12? So we would take our function, and this right here is our x value. So we're plugging in 12 for x. Now, you can solve that by hand. If you prefer, you can just put it into Desmos. And it tells you 11. So you can do that by hand, or you could use Desmos or a calculator to help you. All right, it says select all the points that are contained in the graph of the equation. So the best way to do this is to type it all into Desmos and see which points are on that line. You could plug them in by hand, but that would just take you quite a bit of time. And if you want to do it faster, make your life a little bit easier. Okay. So if we zoom in, it looks to me like the green and the black dots are the only ones that are on that line. So I'm going to take off the blue, the purple, and the red. So our answers here would be 0, 3/4, and 1/2, 1. All right, number 9, this is very similar to the first question that we did. So we have two functions. The first one is f of x, and the second one is g of x. And g of x is created when we take the f of x function and we add some number. So what we're adding here is whatever it takes to move that graph up. So if we start here at f of x, we move up 1, 2, 3, 4, 5. So our h value would be 5 because that graph moved up 5. A grasshopper jumps off a tree stump. The height in feet of the grasshopper above the ground after t seconds is modeled by this function h of t. After how many seconds will the grasshopper land on the ground? So if we think about it, okay, the grasshopper is on a tree stump, okay, and they jump and they come down and they land. We want to know how many seconds, so this x side here, how much time did it take them to get back to the ground? So we're going to put this function into Desmos. And make sure we're using x here. Desmos will not read t or h. Okay, so here's our function. And like I said, we're looking for this point over here. So it looks like it takes 1.5 seconds for that grasshopper to land back on the ground. A shipping company charges a cost per pound plus a fixed fee to ship a package. The total cost in dollars of shipping pounds is modeled by your function shown. So this $4.99 right here, that's going to happen over and over and over again. So that's going to be $4.99 per, and then it says right here that F is the cost in dollars of shipping, and then that would be the number of pounds. So F is going to be your number of pounds. So it's $4.99 per pound. And then that $5.75, this is a one-time fee that cannot be changed. So when it asks what the fixed fee is, it's that $5.75. All right, we have a function here. It says, what is the minimum value? So when it says minimum value, it means find the lowest point, and we only want the y value. So when if it said minimum point, we would write the whole coordinate point. But because it says minimum value, we only want the y value. So we're going to plug this function into Desmos and see what that lowest value is. All right, so right here is our lowest point, that's our minimum, and then we want to look at the y value here, which is 3. So 3 would be our answer for this one. All right, we have an equation here, and it says solve it, which means find the x-intercepts, find where it crosses the x-axis. To put this into Desmos, we need to move the 11 force over. So what would happen is we would have x squared plus 6x plus 11 over 4 equals 0. When we put this into Desmos, we only put the left-hand side. We don't put equals 0 in because Desmos just doesn't read that the correct way. And negative 0.5. Okay, so not these two. Okay, and we definitely want both. We definitely want that half to be negative. So it's going to be negative 1.5 on that. Yep, both of those are negative. So just have to make sure we do the right one. Letter D. Ooh, this is a great question. So this is definitely a Desmos question. And it says select all that apply. So we want to type all of these into Desmos. Okay, so our original, gosh darn it.
Our original function is 16 to the 5/2 power. Okay, so we want to find all functions that are equal to this. Okay, 4 to the 5th is, so you can definitely mark that one. 8 to the 5th is not, so don't mark 8 to the 5th. Ooh, this next one. The square root of 16 to the 5th. We can put that in. So you have square root 16 to the 5th. Just make sure that all stays under that root. Now this next one, the 5th root of the square root, I'm sorry, the fifth root of 16 squared. We can't put the 5th root into decimals. So here's how we write this. If we ever get a root, okay, we know that 16 squared is under the root here. The 5th root can be written as a power of 1/5. So real quick teaching lesson on this. If I told you to take the square root of x, it's the same thing as writing x to the 1/2. If I told you to take the third root of x, it's the same thing as x to the 1/3, so on and so forth. So here, we're doing 16 squared with the 5th root, which is the same thing as 16 squared to the 1/5. So when you type this into Desmos, you're going to have to use that particular notation. All right, that one does not fit. That would not be the same. And then I'm going to just type the rest in here. Okay, you can circle 16 squared 16 1/2. Okay, so we're going to go back through it. We're going to check the ones that fit. Put this over here. Okay, here we go. So our original 16 to the 5/2 was 1,024. So 4 to the 5th was the exact same. 8 to the 5th was not. 16 square root of 6. I'm sorry. Yeah, square root of 16 to the 5th was. And then our 16 to the 2nd to the 1/5. This one is not. And then 16 squared 16 1/2. That one is. And lastly, that last one is not. So those would be our only answers for that one. Okay, this one is what two numbers have a sum of 217 and a difference of 85. So when we say two numbers that have a sum, well, two number sum could be written as x plus y equals, and then 217. Okay, our difference could be written as x minus y. You just subtract the two numbers, and that would give us 85. So to find the answer for this one, we're going to plug it into Desmos and see where they cross. This is just a system of equations. Scroll out and see where those cross. Right there, 151 and 66. So if you were to take those two numbers and add them together, you would get 217. If you were to subtract the two numbers, you would end up with 85. So our answers here are 151 and 66. All right, our next one, Ryan works for delivery service. He has a function 7n plus 96, and it says use the function to complete your table. So you can do this all by hand, but a really great feature of Desmos is the table feature. So I'm going to plug in our equation. And I'm going to add a table. So if we look at 0 right here, 0 corresponds to 96. So we can fill in 96. for 0. And then we would go back to Desmos. We don't have 5 yet, but we can type it in, and we get 131. And then lastly, we don't know, we can't type in y values on Desmos. There's no way to type in 145. So we're just going to add, we're just going to keep going. So 6 is not 145. 7, oh, there it is. 7 corresponds to 145. So our x value would be 7 for that one. All right, so some miscellaneous modeling questions here. And modeling is usually going to be a lot of kind of figuring out a word problem. So for number 17, it says the population of a colony of Rodriguez bats is modeled by this equation, which is an exponential. X is the number of years. So what you think about, is this an increasing or decreasing function? Hopefully you're thinking it's increasing because inside that number is bigger than 1. When that number is bigger than 1, it's increasing. And then it says by what percent? Well, in order to get 1.12, we would do 1 plus 0.12. So that 0.12 tells us that it's 12%. The initial population is this value on the outside, which is 60. And it says, what is the expected population after 5 years? X is the number of years. So we're going to plug in 5 for X, and we'll put this into our calculator. So that would be 120.68. So we'll just go with 120 bats because we can't do part of bats. So we would say 120 on that one. A total of 330 children and adults attended a school play. There were 121 times as many children in attendance as there were adults. All right, and they have given you the 2 equations here. Okay, A is the adults, C is the number of children. How many children attended the play? So this is the system of equations. So there's 2 equations, and to find the answer, we want to know where do those 2 equations cross. Well, we're going to transfer these into X and Y so we can put them into Desmos. We'll let X be children and Y be adults. So I'm just going to transfer those over. And we're going to put this into Desmos. All right, we'll see where they cross. Right here at 315 and 15. So we know that that's our solution, but we have to know which one's children and which one is adults. So we originally said that X is children. So this is going to be the number of children, and this will be adults. So our answer here would be 315 for the number of children. The path of a red kangaroo jump can be modeled by this equation, where X is the feet that the kangaroo jumped horizontally. Okay, so we'll say this is horizontal jump. Okay, and this will be vertical jump. Both of them are measured in feet. So we have to keep that in mind. It says, what is the maximum height the kangaroo reaches? So assume that this is kind of what our graph will look like. So right here, that's what we're looking for. So we're looking for that point. And we want to know the maximum height that they jumped. So we're going to be searching for this particular y value for the first answer to our problem. So let's go ahead and put this function into Desmos and see what happens. Okay. All right, so here's our function. If we click on the top, it says 9.75 comma 6. 9.75 comma 6. We're going to fill that in. So that 6 is the height, the maximum height that the kangaroo jumped. Then it says how far is the kangaroo's jump. So if we're looking for how far he jumped, we want to know, okay, how far did he go this way? So where did he land? This is what we're looking for right here. And we're looking for that x value. He jumped 19.548 feet. The population of Bay Village is 35,000 people today. Every year the population increases by 750 people. We're going to write an equation for this. So if it's increasing by 750, we're adding 750. So we'll take 750 per year plus the initial amount of people. It says in approximately how many years will the population exceed 50,000 people? So for it to exceed 50,000 people, we would need to solve for the time, because it says how many years, and number of years is x, because we're doing 750 per year. So we're going to fill in that 50,000 for y. Okay, and you could solve this, or you can put it into Desmos and see when it's 50,000. The only issue we could run into at Desmos is if it's not a really nice number. So we do y equals 750x plus 35,000. We could actually add a table, and we could do it this way. Okay, so you could say 3, 4, 5, and you could just keep going until you get to 50,000. There it is, 20 years. Another thing you could do is you could look and you could drag on the graph. That's fine. Table tends to be a little bit easier. So there's a lot of different ways to answer this one. You didn't want to solve it by hand. So our final answer here would be 20 years. Okay, that is all for this particular unit. Best of luck on the OST test. You are going to do wonderful.